Hello, this video is going to deal with CAM, computer-aided manufacturing, and generating toolpaths using Inventor HSM. And this video actually is going to be HSM setup, things we need to do to get started before we actually start creating a toolpath. Okay, so first obviously we have to build a CAD model or a 3D model, 3D solids. It really depends on the software package you're using, whether I'm using Mastercam or Inventor HSM or a few other ones. You're going to have to build a CAD model. So we have our 3D solid CAD model. Here are all of my features. And speaking of features, some people like to do holes. They just make a circle and then they cut it down. And it does achieve that. But if I were to make a working drawing, top, front, right side view, and dimension it, and have hole callouts and all that stuff, I won't get any of the detail information. Okay, like this is a tapped hole. It's drilled a certain depth, it's tapped a certain depth, it has a countersink on top of it. Or if I have a hole that has a counter bore or something along those lines, I don't get that information. And so when I make my working drawings, I have to type all that in instead of getting it for free. I like free. So here's what I mean by that. So I have a hole 1. I'm going to right click and I'm going to edit the feature because the feature is all that information. And here's what I have. If I come down here, I have picked a threaded hole and set the size hole 1032 UNF, number 10. So it gives me all of these choices. So I have set my countersink diameter to 205, which is slightly bigger than the major diameter. So I have a nice little chamfer on top. I can control my thread depth, I can control my hole depth, and the angle of the countersink. We will be using in our tools a spot drill that's a 90-degree spot drill, so that's why this is 82. If it was a countersink for a flathead screw, American is 82 degrees and metric is 90. So it would be different, but this is just a little chamfer to create a nice edge. But so all this information is here, and then if I were going to go and do a detailed drawing with dimensioning and hole callouts, I get all of this information for free. There is things that transfer over and automatically get recognized as a feature in the CAM portion of the software. So it is definitely worth it to do it as a point and then creating a whole feature. Okay, so my CAD model is complete. I want to start CAM. So here's the CAM tab. So we normally see 3D model, sketching. So I'm going to pick CAM tab, and these are all my choices. I can simulate it when I have something. When I'm all done, I'm going to post-process it. I can create a setup sheet, a number of things that I can do, drill a hole, face, 2D, 3D. Here's turning if I was doing a lathe work. And here are some ways that I can look at my part, tool top, tool front, tool right. So that's relative to the tool coming in. Tool isometric is the way that we're looking at it. Okay, because here's my world coordinate system, Z is up, X, Y plus, X plus over here. So oftentimes the first time I go in, when I pick CAM, it automatically changes this to CAM. But I've been in this and come back out of it. So here's my modeling stuff. If I pick this, I can pick CAM. So the first time I pick CAM, it generates this, the name of it. Okay. So to begin with, I need to set up. Setup's the first thing you're going to do. So setup's going to define a number of general properties, okay, including my work coordinate system, because my work coordinate system might not be the same as my world coordinate system, which we use to create the 3D model. So we're going to go into setup. It automatically has some defaults. Those little balls here are points that you can pick to put your 0 at. Okay, there's 3 tabs over here, and you basically work from left to right all the time on these tabs. So in setup, I am going to do milling. I could do milling or mill turn. So my work coordinate system, I'm going to use, I have choices. And if I hover, it gives me this flyout that shows me some definitions of all of this stuff. I want to use a model orientation. If by chance the X, Y, and Z over here was not in the direction I want to work from, I would have to pick one of these other ones so that I could try and make it the way that I want it. But I want it the same orientation as the model. Stock box point, the origin, that's where my program 0 is going to be. Do I want it to come off of a stock box point? Again, it hovers. Stock is there's stock added to it. I want it to be relative to my model origin. No, I take that back. Look, that's where my model 0 is. I want my program 0 to be in my upper right hand corner because my stop's going to be on the right side. My solid jaw is on the top. So I need upper right hand corner. So I don't want model orientation. No, I'm sorry, I do want model orientation, but I want it to be right. It was stock box point. I don't have stock on the sides, so I want model box point. So what it does is it moves these points in, and I'll show you what I mean. Let's look at the front. So it moved it into my model, my 3D model. Go back to tool isometric. Model box point. And so now I can pick any point that I want and it will put my 0 there. So there's my upper right hand corner. So now that's set. Okay. Now I'm going to move over to the next tab, which is stock. There are choices: relative box size, fixed box size. That's where I can type in a size and it distributes the stock evenly. From the solid, I'm going to pick relative size box. I can choose where I want the stock. Add it to all sides, add stock to sides and top and bottom. I'm going to pick that one. Even though I don't want any side offset, it gives me choices as far as where I want the stock. Am I going to put stock on the bottom for a next operation? Do I want it on top just so I can clean it off? And I want none on the sides, so I'm going to go 0. And on my top, I only want 30 thousandths. And so it parametrically changes everything. So you can see stock on the top, nothing on the side. There's a little radius here. That's why it almost looks like it, but there is no stock there. Okay. Post-process, next thing. My program number, my program name, this is where the O word comes in, and then I want a comment. So I'm going to go over here to my tool sheet. You got to have a tool sheet before you're doing this. I have to have a list of tools and I have to have some information. So this is 00101 is my program, and I'm using work offset 54. So let's go back to our thing. So it's 00101. I'm going to set my work offset 54. When it says 0, that's equal to G54. 1, G55, 2, G56, 3, G54. Okay, so I'm going back to 0 because I want G54. Okay, I'm going to come back up here to program commands. So what you write, this is the first line of code that's going to come when you post-process after the O word of 00101. So in this, I want to have part name. Okay, so this is going to be CAM training first operation, and I'm going to put my name, Bart's. Okay, this is done. Okay, now it added it here into the browser just like the others. So next order of business is I need, when I pick anything, so like I said, we wanted the face. If we look at my tool sheet, I'm going to need a 2.5-inch face mill. I need all of these tools. Okay, I have already calculated my speeds and feeds. I know how many flutes. this should be the correct RPM. If I did my math right, based on the chip load, I should get that. So we want to build this into our tools so that when I call up that tool, the right information comes in. Because I guarantee you that's what's in the machine is not there. So like, let's say I'm going to face first. It pops it up and it automatically populates some information in here. Well, I got to pick a tool. Here's a face mill, 2-inch. So it already populated it. So as I pick a different tool, you'll see it changes these numbers over here. But I don't want to do it that way one at a time because I'll forget. So cancel, and it got rid of that. I can come up here to Tool Library. I want to create my own tool library. Okay, so it kind of starts one out for my part. I don't know what all this other junk is in here right now, but it shouldn't be anything. It may be that I picked these and whatever, but let's delete all of these because I don't know where they came from. Yes. So I should have nothing in there yet. So I want to create a new library. Okay, and the reason I want to create a new library is because I know I'm going to be making more programs beside this one. So I want to make my own program library. So I'm going to pick this, and that's some library named New Library. So if I pick, right-click on New Libraries, My Libraries, I can create a new library. I'm going to call this CAM because these are all my CAM programs. Now, enter. Now, one of the things you need to know is this library is relative to this machine only. In other words, I go and log on another computer, my CAM library isn't there. The good news is, though, in this Inventor HSM, my CAM program, it is creating one that will stay with the part. Okay, but if I only, let's say, didn't create a tool library and just stayed over here and did operations and assigned the tools as I went along, if I have to create tools, I'm not going to have it. So I'm going to create my library first, CAM, but I got to find my tools. So we said that was a 2.5-inch. Now they list things by type of material, inch, metric, taps, ISO is American, ANSI is metric, sample tools for turning, tutorial tools. I'm going to pick tutorial 2-inch. Oh look, there's a face mill. But it is not the size that I want. I'm going to have to copy it. I don't want to modify it in here. I want to leave this original one there. So I'm going to right click and I'm going to say copy. I'm going to go up here and I'm going to go into my CAM library and I'm going to right click and I'm going to say paste. Okay, now I can pick this tool and I can pick edit. So I'm doing this in my tool library. I'm going to build all the tools in my tool library and then they'll be there for any time I want to come back. Okay, so general, tool number, offset length number, offset diameter, all those should always match. Okay, do I want coolant on or do I not want coolant on? Okay, what type of material am I cutting with this? Or I take that back. Is the tool made out of? I'm going to say it's carbide because I have carbide inserts in this. And it's a 2.5-inch face mill. And I always take and I always copy the description, Control C, Control V, and I put it in the comment because it'll show up in my program. Okay, so cutter, let's go to the cutter. I can change things here. My cutter diameter is 2.5, 2.5-inch diameter. 0 corner radius. Most of this stuff can be the same because it's just kind of a visual picture that I'm going to see. The main thing here is I need the diameter. I could change the shaft and the holder and geometry. I'm not interested. But I do want to set my feeds and speeds. Okay, I want them to match my tool sheet. I forgot, so we have to go back. 2.5-inch face mill, 5 flutes. My cutting speed is 1963 and my chip load is 1 6/10 per flute. Okay, 5 flutes. Number of flutes 5. Surface feet 1963. It automatically changes my RPMs. Feed per tooth was 0.0016. It automatically changed it, so I've got a plunge feed of 50, lead in of 65. Okay, so that's what my feed rate is. This feed rate is not correct. That was 1963 was the feed rate. Interesting. Why is this doing this to me? Let's go back and look. Was my RPM 1963? RPM is 3000. Let me try putting in 3000 RPM. 3000 RPM. It gives me 1963. I don't know why it wasn't letting me plug it in there. Feed rate's 30. Cutting feed rate 0.0016. Feed per revolution. That's fine. Now these are my lead in and lead out and my ramp feed rates. Well, if this is my cutting feed rate, that should be the same. And my plunge feed rate should not be more. So let's make it the same. And this feed rate should be the same as my cutting feed rate, 24. Good news is when you change it here, it stays. Feed per revolution. Oh, that's not what I want. Here it's feed per revolution. Here it's feed per tooth. So I gotta say 0016 times 5. Eight. Okay. Sometimes you want your vertical, if you're coming onto the part, you're going to want your vertical feed to be half. That's rule of thumb. This is coming off the part, so I'm going to leave it the same. Okay. So I have my speeds and feeds correct. I have this info. My cutter's 2.5-inch diameter, so I'm okay. So boom, there's my face. Okay, so that's how I build a tool and put it into my library. Okay, I can say okay if I'm done. Any changes I make can't be undone. Okay. So now if I come back to my tool library in my CAM, I have that tool that's set up to be the way that I want. It's a face mill. Here's my description and comment. If I make this bigger or move over, it shows me stuff, my speed, my RPM, my library that it's in. So that's there. So that is how you set up and you build a tool library. And again, I would build all of my tools in the library at the same time. And then I have a done library. And that's all for HSM Setup. And we'll be back with how to create some toolpaths.